Hello, everyone. It's been a hot minute since I posted something. So, KNIME has this Just Name It challenge, which I thought is pretty interesting. So, I thought it's pretty interesting because I figured it's gonna be a nice, fun application of LLM. So, this is a challenge, and you're supposed to try to detect fraudulent contracts. So the data set, it has a bunch of contracts, which I downloaded, and these are the contracts. I'm gonna just give you a very brief overview of my KNIME workflow and I'll show you how I used AI. It's super simple. So here's my workflow. Basically, I read in all the data, so I read in all the PDFs. I actually did two approaches. So I did test a case where I filter out stop words and punctuations, and I tested a case where I don't do that. I will show you the different results. And then I get the document text, and I create some counters because I wanted to have some short IDs so that I reduce my tokens as much as possible. I then dropped the document column because, again, once you extract information from a PDF, it brings it as a document data type, but we need to be able to send textual data to the model, which is why I extracted that text, and then I just dropped the document column because I don't need it anymore. And I rename the counter to ID because these IDs is going to be what the model uses to identify the contract. I drop some part of the text which is just repeated. So like here, like this first long string is just repeated. So instead I'm using like a shorter string so instead of saying all of this, including the address of the bank, I just have something short. So mine is way shorter. My introduction to the contract is probably about maybe what 15 tokens, and the original one is probably maybe 40 something. So I'm saving some money by doing this. Then I resort the columns because I want the ID to be the first thing. So that's once I combine it, I have the number. I have the number which represents the ID of the contract, and I have the contract text. Then I do a concatenation to have one long string that pretty much has all of the contracts and their IDs. And then I call this contract. So the contracts go into a variable which is fed into the chat model. I've already set up my OpenAI nodes. I'm not going to go over those because I made so many videos on that. You can go watch those if you want to. So here, I just prompt the model. I give it instructions to identify which contracts are outliers. So I let it know my data structure. I let it know that the ID precedes the contract text in the form ID column contract text. And I let it know that new contracts are separated by delimiters. And I tell it to reply back to me with only the IDs, because if it replies with a bunch of things, it's going to cost more money. So I only want the IDs of those contracts which are outliers, and they can be fraudulent or they can just have errors. So I put in my I select my role and messages from my template table, and my message, which is the list of all the contracts, is in a variable which is fed into those messages. And then I run that, and the model believes that 3 of those contracts seem to be outliers. Now, when I ran this, by the way, I'm using the 4o mini because the 4o mini is the only model based on my OpenAI account, is the only one where I can use above 40,000 input tokens, which is about what I have here. So yeah, so it identified 3. It said 3 of them look like outliers. When I ran it with taking out stop words and punctuations, it only returned 2 potential outliers. Okay, so these 3 guys, now I'm going to open them. Okay, just eyeballing the contracts which were identified as fraudulent by the model and the ones which were identified as normal. It looks like one major difference is the amounts. The amount of the supposed fraudulent ones are a lot bigger. So this is almost €250,000, whereas this is not even up to 1,000. This is just over 1,000, and this is about 2,000. And this second fraudulent one is the same thing. Now this one is not. And remember, actually, this one is yeah, this one I believe is the one. So 29 maps onto so in my table 29 maps up to 29 maps onto 68. So 68 is the last one that it thinks is fraudulent, and it only thinks this is fraudulent if I do not remove stop words. So that might be a thing to consider. If I do remove stop words, it does not give me this. Now, let's just do an experiment. Let us ask the model to also justify why it has told us that these things might be fraudulent. With the IDs of the contracts, which appear to be outliers, and a brief explanation as to explanation. Oh God, it's gonna get my typos of why you consider each outlier an outlier. Okay, so I'm gonna run this now. Let us seek explanations. It is here because it looks like there's some truncation going on. Okay, so now it's even seen more outliers. So for the one with 20, the payment amount is significantly higher than other contracts. Okay, yeah. For the one ID1, the payment is relatively low compared to the average amount, but it's not an outlier in terms of product type. That's pretty good. It's looking at the product type. However, the context of the the context of the contract suggests it could be part of a larger scheme, especially combined with other contracts of similar nature. That's interesting. 18, the payment amount of 9.1 euros is usually low, unusually low. Yeah, I would think that. And then for 44, the payment amount of this is extraordinarily high. Is extraordinary. Okay. So, and then 44, the payment amount is extraordinarily high, and then this one is too low. By the way, the interesting thing is once I asked it to give me justification, it's actually pulled out even more potential outliers. But this whole comment about part of a larger scheme, I'm not quite sure what it's on about here actually. So that's interesting. Anyways, I just want to briefly, for some benchmarking, I want to show you guys the results from KNIME. So I do have KNIME's the solution they posted here, and I open it, and we can see that the contracts ending in 15 and 19 are seen as outliers, and our model did detect these. So 15 and 19, these map on 15 and 19. So 15 maps onto 44, which our model found, and then 19 maps onto 20, which our model also found. Our model also found other ones on the low end, so perhaps this is maybe even a more comprehensive way to do it. I am going to post this workflow once I clean it up. Right now I have to go play my VR. I need to go do some VR workouts, so I'm probably going to do this in the next couple of days, maybe about the weekend, and I'll post the workflow. But I'm gonna post this video because I think it's a fun approach and potentially very useful. All right, thanks for watching. Have a great day. Goodbye.